Hi, I am Cal Sitter, and I'm with the Robo Raiders Team 7129, and I'm going to be talking about our new collection. A little bit about our collection. This is a dual rubber band spinner. This is our old collection, and I'm going to be talking about how we got to this design and kind of the steps we went through, because this design is unique to this season. So a little bit about our old design and how we got to our new one is our old design is a simple mold of the cone and uses servos. It was on the robot like this. It would come down and collect the cone like so, and then go up to pretend this is the pole here, and then score it. In that, our first and second meet, we did data collection, and we figured out that we lost most of our time in collecting of the cone because when we would drive up, because we have a turntable on here, with inertia and stuff, it's a little bit off, so it's really hard to line up and actually grab the cone. So there was a lot of time lost in that. So we figured out that we needed to go to an active collecting system like this. With our active collecting system, we went through some earlier iterations, as you'll see on your screen now. But what it practically is two rubber band spinners, and then we have a funnel type system here, and then just a servo with a linkage that uses it to put it in its right direction. We can adjust the angle of a rubber band spinner. And so whenever we collect the cones, so one thing we've been doing this year, in order to fit inside the 18 by 18, we actually have to close our collection all the way so it fits inside 18 by 18, but then with the linkage, we can then adjust it to about a 45-degree angle, allowing us to then collect the cone. The reason we chose a 45-degree angle is because whenever we are collecting the cones, it helps with driving up rather than going over top, because that's our design now. There was a lot of flaws in that. With the 45-degree angle, whenever the cones are stacked like this, we can drive up, and then it intakes them in. It also is helpful for autonomous whenever we have the full stack of cones, because when you come in a little bit at the top or not a 45-degree angle, it moves the whole stack of cones, and as we all know, that is a penalty. So with the angle, we are able to drive in and slowly grab the cone, but also come in from the top and grab it as well. So we have options there, and then score whatever junction we want. Another thing is our funnel system here. As you see right here, this is kind of our first design iteration. And on your screen, you can kind of see the iterations that we went through. But this was the first one, and we figured out that with the active rubber band spinner, the cones would not go in straight. They would either get stuck like this, or even when sometimes in taking, they get stuck like this. And that just did not work. So we first started with these red pieces here. But what that has allowed us to do is when we collect the cones, similar like this, but it has the curves on the bottom to allow it to come in at a different angle and still straighten out. We also have a little hook here on the back. We put that in there first to keep the cones from getting stuck like this. And though that did help a little bit, but it ended up actually making the cones just get stuck farther down. So we figured out with making a ring, that worked way better as a funnel because when it intakes, it automatically adjusts the cone straight. So even if the cone is coming in at an angle like so, it's mostly straight. And that's the goal, right? Because we don't want the cone coming in like this, as long as it's somewhat parallel to the junctions, we're going to be able to score it. Another thing, with the 45-degree angle, we're actually able, because our lift here isn't able to hit the exact height we want it to, but with the ability to adjust the angle of our dual rubber band spinners, we're actually able to then go up to the high junction at a 45-degree angle, giving us more height, allowing us to either lower the cone onto it to make sure it's on there, or sometimes when we finesse it just right, we can release it like this onto the junction. Whatever. Also, how we power the dual rubber band spinner is just by a 20-to-1 Navarez 2020 motor that comes from this spool here, and then these spools here that then run down to this spool, which then powers the bottom. But also, as you see over here, our belt is crossed giving us that opposite direction to actually use the intake, to actually intake the cone. The reason we did this is because with gearing and sprockets and chains, that's really heavy. And as I've kind of stated before, with it being heavy, we wanted to optimize our weight and get it down as much as possible, because when we're storing the high junction, all that weight on top is really tough, and we don't want troubles with our robot tipping. And not only that, but with the turntable, inertia is an issue. So the more weight you have on top of it while you're moving around, the less accurate it's going to be. So that's kind of a basic overview of our dual rubber band spinner. Again, we just wanted to let you guys know because it's a little bit unique to them this season. A little proud of it, but hope this is helpful, and good luck to all the teams out there.